at Boyle's temperature, which of the following happens? Now remember, at Boyle's temperature, the real gas shows ideal behavior over a large range of pressure, right, at the small pressure region. So let's see the options. The effects of the repulsive and attractive intermolecular forces just offset each other. Exactly, this is true because for a real gas, the molecules can either repel or the molecules can attract, right? And if the molecules repel, then the volume attained by the gas would be higher than that of ideal gas. And if they attract, the volume obtained will be lower than that of ideal gas. If it is exactly equal to that of the ideal gas, it means that the repulsions and the attractions between the molecules are exactly balancing each other, okay, and giving an absolute ideal gas behavior. So A option is correct. The repulsive intermolecular forces are greater than the attractive intermolecular forces. Now, if the repulsive forces are greater, it would mean that if the ideal gas had to occupy, say, this volume, this gas would occupy this volume because repulsion is higher. And if the attractive forces are higher, as in option C, okay, then if the ideal gas had to occupy, say, this volume, the real one would occupy this volume. That is, the volume occupied will be smaller than that occupied by an ideal gas. Then talking about B minus A by RT. B minus A by RT is positive. No. If we are talking about the Boyle's temperature, it would mean that the gas is behaving ideally. So B would also be 0 and A would also be 0. So that the equation simply becomes PV is equal to nRT, that is the ideal gas equation, without any correction terms. So the only correct statement for this question will be statement A.